Assalamu alaikum wa rahmatullah. Welcome everyone to quality improvement methods, and today we will talk about the improve phase of the make methodology. In the improve phase, the unique about the Six Sigma is that can carry many methodologies and many applications in the improve phase, and that's what distinguishes the Six Sigma methodology comparing with other improvement methods. And that's the reason why the success and the widespread of the Six Sigma methodology. For example, in the improve phase, you can use any methods that can improve your process and reduce variability, which is the objective of the Six Sigma methodology. In our case, for example, here we can have operations research, linear programming optimizations as a method for improvement. We can use simulation to implement your improvement plan into a software package that simulate the process before you do the changes which will cost you. Or also you can use simulation to compare your current status with the future expected process after the changes implemented. Software development, you can end up with developing a software package. Nowadays, Internet of Things that is widely applied, a phone application, smartphone application that can be an improvement method or improvement tool. You can use it in the improve phase to reduce a variation, for example, in the process. We can have an example, Tawakkalna or Abshir applications that we use in Saudi Arabia. Those are highly efficient in terms of the processing the transactions compared to the previous what we had in the previous situation when you used to go and visit the government sector office location physically, and you have to proceed there, which that will reduce amount of time in by having everything's that done using your phone application. Lean principles, and we have learned some of the tools for lean to reduce waste along the way while you are reducing the variability. Quality management, it could be like authentic institute or authentic association or organization to certify your process or you certify your product. For example, in education, we have the National Accreditation Center or agency, NCAA, and we have also ABIT, which is emphasizing on accrediting engineering programs to reduce the variability in the teaching or in the education service in general. Utilization, your resources, facility planning. This is all discussed in a whole separate course in the facility planning or facility layout, where you utilize the space and the work floor in a way that you can have the best in terms of the environment where is your staff working. Supply chain, operations planning and control, where you can implement forecasting. So your improvement would be projected and calculated. Benchmark, where you can compare yourself with the best practice and you implement the best practice in the improve phase for your current project. Reliability study, and this is a whole different and another discipline that you can study it in the quality, which is designed for the reliability. Ergonomic design, you may end up with designing a product or a device ergonomically to reduce fatigue in the worker, so it will reduce the variability of their performance in doing the job. So all these can be carried along the way in the improve phase while you are implementing the make framework. Moving on with some other tools that we are going to cover in the improve phase, and we are not limited, as you can see, to those tools. It is all open to all methods can be integrated with the Six Sigma methodology as long as it serves the purpose of the project. For example, here we have a method or a tool commonly being used even in our daily life. We see it, mistake proofing or poka-yoke. Poka-yoke is the Japanese term for mistake proofing, to reduce the defects from happening. The mistake proofing work in preventing the occurrence of the defect and prevent the error from being a defect or converted to a defect. It detects the defect, and it works in two approaches. The first one called the warning approach, and the second one is the control approach. As we stated, the poka-yoke is meant for preventing the errors from happening and converted to defect. So that's the concept of the poka-yoke. And what is the difference in the approach? One approach works in providing signal to the user or the operator when defect occurs, whereas the control approach works in stopping the process entirely when the defect occurs. So maybe the question will say, okay, should I use one of them? If it's possible to use both of them, that will reduce the defects in your process more and better by using only one of them. It is good to have signal or warning signs to reduce errors from happening. At the same time, it is good to have in your system such feature to stop the process when a defect is occurred, to prevent that from producing defect products or defect services. An example for warning approach we can see daily. For example, if you haven't wear your seat belt in the car, then the alarm will start beeping in your car. So that's the warning for you and prevent you from having driving without a safety belt. A very simple example also, we can see it in restaurants, having the ketchup and the red bottles here, like the picture, and the mustard in the yellow bottle, to reduce the error from having one instead of the other, or mixing between them. By just looking to the color, the brain will easily distinguish between them. Now, you can look at as you as someone in the restaurant and eating and using those, or maybe you are in the kitchen who's working and making requests for customers for food. So instead of having defects, by having one instead of the other, that will reduce the amount of defects and mistakes by just coloring the bottles. Or, for example, the cold water that's signed in blue and the hot signed in red, also for the same purposes, to warn you from having an error or mixing between them. The control approach can be found in different applications also in our daily life. We see it. Nowadays, cars are occupied with adaptive braking system that will stop the car completely before an accident. So if you reach to the close to the car, that front of you very close, and you are about to maybe crash that car, so the adaptive braking system will automatically control the car and stop it. It may vary the application between company or automaker to others. Some they reduce the speed, some they just give you a warning, but also some other companies goes to the control level where they stop the car completely to reduce the chances of the defect. Also, the circuit breaker or the switch breakers, we see them in our houses. Those are very useful to prevent from fires due to overload in your electricity sockets by maybe having too many equipments connected to that socket. So how they work, if there is overload in a certain electric socket in your kitchen or in your home, so the circuit breaker or the switch breaker will turn off the electricity to be fed to that socket, so you don't overload it, and then it will cause a fire. So these are considered to be an example, very simple example for control approach. So the mistake proofing, it's an approach. You can use any tools along one of those approach, with a control or warning. Signs, for example, instructions, how you use the equipments in the lab. This is considered to be warning approach to give the user or the operator or even the students, when he's operating that equipment, the instructions to avoid mistakes or defects happen while operating that equipment. The safety signs considered to be also a warning approach. The fire alarm, it's considered to be a warning approach. The control approach is the water sprinkles that operated when the fire alarm started, considered to be a control approach to spread waters in the case, or in the case of fires. Another examples, we can see them here from our textbook, talking about intersection point between cars and the train railways. And this is considered to be a dangerous point where accident could occur, and how they have used or implemented the POCIOC in this case by first analyzing the source of the inspection or the source where it could happen. And they found it in the car drivers mostly, because the train usually travel in a railway in a specific path, and the control for the trains is not as in the cars, because it's already determined the speed and the length of or the path for that train. Whereas the cars can go and intersect the point at any time if the driver, he's not focused, or maybe he's driving and he was distracted while he was driving. So this is considered to be where you have to focus and implement to reduce the source of that mistakes or the defects, in this case, in the intersection point. One of the application for the warning approach of the mistake proofing here, we have the traffic lights. Obviously, the traffic lights will give a warning to the driver that if it's red, so he cannot cross that intersection point. But also, maybe it will not be enough, but having another approach like the control approach, in this case, having an automatic gate that can shut off and open automatically when the train crossing that intersection point, that also will prevent from having an accident and cars approaching the road while train is running. All these two, as you can see, both of them, the warning and the control could apply. One of them can apply. This is dependent on your case and the resources you have in your case. In this case here, we had accident can only occur after this implementation of the warning and the control, if either the control, which for the gate was failed, or there was a technical problem in the gate, or that the driver intentionally drive around the gate. So here you reduce the defects from occurring, although there are chances of occur, but it will not be the same as when you didn't implement only those two simple, considered to be applications for the mistake proofing here in our example. Moving forward in the improve phase, having an additional tool or a new tool to be introduced, which is the SMED. SMED stands for the single minute exchange of dies. And the SMED, it's another approach that you can use it to reduce the setup time and the change over time in production line, in factories, in services. There are usually setup time or change over time. If you go to a production line, you see sometimes they have to set up the equipments before they start producing, or they have to change some settings in the machines if they are moving from product A to product B. Also, if you think about it, doing your car maintenance, this is considered to be setup time or change time. Changing between one operator to another operator in the shift considered to be setup time. Sometimes the maintenance you do on the website that's serving customers considered to be changeover or setup time. All these are examples of the setup times. And SMED trying to reduce the output and quality losses due to those times. So your output will be reduced if those times are increased. And in most of cases, the setup time and the changeovers usually from historical studies is less than 10 minutes. So if it is exceeding than that, then that's even more than what it should be for any process. But some process, as we will see, fraction of a second, it could matter and it make differences, as we will see in coming example. The setup time and the changeover classified into two classifications. The first one called the internal setup, and the second one called external setup. The difference between them is the internal setup is the changes that need to be done or in the equipment or in the software application you have while the machine is off or while the website is down. So you cannot operate that time while you are doing this setup, and they call it the internal setup. And there is the external setup, which is changes or operation can be still or setups can be still done while the machine or that, for example, the software or a website operating. Maybe you faced before a time when you visit your bank website or web page and you see it's down for service and maintenance. Also, it could be sometimes it's working and they are conducting some maintenance behind what you see in the web or in the page. So that is the difference between the internal setup concept and the external setup concept. The internal things, you have to do it while you shut off the machine, you stop the production line, and you proceed to do them. The external, you can do them while it's working. So if you think about it, the internal setup, it will reduce your productivity if you have a long internal setup, while the external setup, it will not affect your productivity. You can still produce while those setups are conducted. So the concept of the SMED approach is to convert all possible IS into ES. So all operations should be done while the machine stopped, to change them to external setup so they can be done while the machine is working. As much you can convert from IS to ES, as much you can improve your productivity and your output in terms of the production quantity. So you remove by how? By removing the non-value added operations. You may find operations can be done faster, can be done while some or part of the production line is working without affecting the overall production. Or maybe some of the steps, if you have enough people to do them, it can be done while the machine is working. So all these non-value added operations, to identify them and how you improve them or remove them from the internal setup into external setup, you do that simplifying the design of the machine, or sometimes allowing to your website to still serve your customers at least for the basic service transactions and the most common frequent transaction appearing. Try to have, for example, if you have machines, try to have simple mechanisms for tightening and adjustments, balance the work content of the line, and ensure teamwork. As we said, sometimes it's the number of resources, number of people working on that issue. If you increase it, that will reduce the internal setups and put it into the minimum, and minimize the trials. Try to have your internal setups, if it's need to be done while the machine is working, doesn't have any trials, mean that the operator, he doesn't have to try and make sure if that device fitting this equipment or this component fitting that machine. There is, if you reduce this time of the trials, that also will reduce the internal setup. So any dimension you can take in changing the internal setups into external setups, that will work and serve the purpose of the SMED. For example, here in the figure, we have a packing machine, and the internal setups and external are demonstrated here in the total setup time, which is the existing status, and they have the internal setups in the light gray in the middle here, and the external, which is the one done while the machine is running, is in the dark gray here. So the improved process, you can see now the external setup is overlapping with the internal setup. So most of the tasks or the operations are done while the machine is working, and they are overlapping. So eventually you reduced the time and you improve the productivity, because now the productivity can be during this duration instead of the complete duration here. Okay. Another famous example, and it's very simple to explain to you how this could be taken into different applications. In Formula One competition, in this type of sports, fraction of seconds make difference. The race is running while you are doing, while the car is doing the pit stops. And as you can see in the left picture here, in 1950, the pit stop average time used to be around 67 seconds. And if you look to how in videos online, how those steps, or how many steps they needed to change those tires for the car while the race is running, you could tell how it was very complicated and hectic. This is more than 1 minute just to remove the car. This guy here, you see him, he's having like a hammer hitting the tire so he can come off, and then he will take the other tire and place it here by himself. Where is the other guy? He's working also in some tools or some places where they can loosen the tires here. What we are here trying to compare with in 2019, if you look how even the amount of people working on the car is more than the double, and eventually the average time went from 67 seconds into 3.27 seconds. So that more than 100% like improvement for the utilization and the efficiency. If you see here, while he's removing the tire, the other tire also is ready to be installed by another person, so that also will cut time. Those two, they have, everyone here you see in the picture has a specific job for a specific duration of time to be done. There is no trials. If you see this video, and you can search it by just having in 1950s, how was the pit stop, you can see it on YouTube, how he was hitting these tires over and over until it comes off. So this is part of the trials we were talking about. Here, they even the design, they change it in the way. This guy here, he has automated screwdriver removers, and those bolts are on مسامير for the wheels اللي هو التايرز والجنوط. It was designed in a way it's very simple to be removed. One person is removing those joints or bolts from here. This guy is removing, this guy installing, and then this guy again. All this simultaneously done in the all 4 tires at the same time. So that's an example of SMAD in sport industry, and it can be in other industries as well. Moving with the other tools we have today, a very good tool, and it is completing the picture of how you improve the productivity and how you reduce the non-value or non-added value steps in your process. I see them, they work together sometimes, which is the SMAD and the OEE. The OEE stands for the overall equipment effectiveness, but here we don't have it as an approach. This is more as an index. So it is calculated, it is mathematical approach or a mathematical tool for measuring the performance. The method is highlighting the losses and identifying the opportunities for improvement. How it highlights the losses? By focusing on the overall effectiveness or overall the quality equipment. Whatever applied on the equipment, you can apply to the service, into considering 3 major factors for that, which is the availability, performance, and quality. The availability is the net operating time over the planned operating time, and the performance is the net runtime over the planned runtime, and the last, which is the quality, the good parts over the total parts. The maybe question could come, what is the difference between the runtime and the operating time? You may work for 8 hours, but what actually is happening in terms of the running the machines during this 8 hours, it could be only 6 hours. So that's the difference between the operating time, that's the total time you have for the operation, and the running time, what is the actually the machine is running or producing goods, or the service is proceeding transactions. We will take example to explain this concept, but before we move on with the example, we have to just highlight some of the causes of deviation in operating time, and you should have considered it when you implement Six Sigma methodology to reduce this deviation, which will reduce also the variability of the output and reduce defects. A lack of personnel, you have lack of resources, warm-up time. For example, you have equipments need to be warmed up before you use it. Idle run equipments is running, but there is no material, for example, so is not producing. Personal under productive time, so you have some employee, he is not productive as it should be. He's working in 8 hours, but his productivity may be 2 hours. Technical failures, defective materials you may have, lack of information, handover to new shift that cause also deviation in the operating time, the setup. All these considered to be a source or causes and the deviation of the operating time. So the operating time sometimes it's be more and sometimes it gets less. Now we will go and identify and clarify the different times we have in the OEE tool. In the OEE tool, you have to identify and distinguish between the different times in terms of the operation. In order to appreciate the usefulness of this tool, we have to understand the equipment time in general and analyze it as shown here in this picture. Then we move on to the mathematical formulation, and then the mathematical formulation will give us how we calculate the index that will make the interpretation for the process and how good is the process is running. We start with the total time. The total time is the maximum time in the reporting period. We will explain more when we come after we define them all. The available time is different than the total time. What is the available time? Is the time during which the machine or equipment could be operated within limits, regulations, or convention. So between those two, the total time and the available time, the difference is when you have some regulations for the working or where your let's say your equipment can be working or your factory can be working, your store, your shop, your service can be provided. For example, the restaurants different, for example, than the banks in terms of the total time and the available time. Restaurants, they have the permission or they have the legality of working 24/7, whereas banks in general, except maybe the branches in the airports, and those they have maybe some limited services they can provide, they follow a different regulations in terms of the working or the availability. So this is to identify the difference between the total time and the available time. The available time, that is the total time minus the unavailable time, which is caused by something that you cannot control it. Now, moving on to identify more equipment time, which is the operation time. The operation time is the period during which the machine or equipment is planned to run for production purposes. Your restaurant or your store is planned to operate for from 8 to 4 p.m. You chose that to be the operating hours. The one you planned is there are some downtime where the your store or your machine or your equipment or your services will not be provided, but those are planned downtime and it can be controlled. You can increase the operation time or you can reduce it because this is not following regulation. That's something you cannot control it. The maximum, the production time is very similar to the operation, and the only difference is after adjusting the operation time from the routine stop, for example, prayers, the setup time we have talked about in the previous tool, also this considered to be routine stops. It has to be done while the operation time. So when you remove them, you get the production time. So the production time is when you remove the routine stops from the operation time. The routine stops, something that happens normally in your process. For example, as we say, prayers, setup, changing ingredients or changing the oil in the fryer in your kitchen if you are a restaurant, so on. These are routine stops, has to be done during the production time. Now we come to the last one, which is the most important, is the effective time. The effective time is the production time minus the unexpected stops. Those stops appeared in your equipment or your factory or your service that was not considered to be either routine or nor the planned one. So the effective time is the remaining time where you actually producing good or you're producing or processing transaction. Is the actual where the production where the units are produced or the service transaction is being processed. Any other than that is not considered to be, and if it was not routine stops or planned time, then considered to be unexpected stops. So the effective time is the actual time where you are producing. Okay, we will take now an example and it will explain all these terminologies and define the numbers, and it will make more sense. Consider the production data for of a toilet soap, صابون أعزكم الله اللي هو دورات المياه, packing line. So it's a packing line for those toilet soap, and this production or packing line is having every case, يعني every bag الكيس contain of 144 tablets. يعني كل كيس في 144 حبة يعني or block حق صابون هذا. So this is what is this machine is doing, is doing the wrapping اللي هو packing, التغليف. And how is the performance, the current status for that is given in the table in this example. Week number, they counted or they measured these numbers in week number 31. This is يعني not going to add for our case or the solution any, but for them it could make difference because they are collecting samples in different weeks. The operation time, it's 128 hours. The specified speeds, 150 tablets per minute. Not bag, not case, pay attention, it's tablets. 150 tablets per minute. And if we are going to work with hours as all the unit time here given, so the 150 tablets per minute give us 150 times 60, which is going to be 9,000 tablets per 1 hour. So we have 9,000 tablets per hour, which is equivalent to 150 tablets per minute. The good output, that's mean the output of these tablets on that week was 42,000 and 32 cases. Routine stoppage or routine stop time, recall to the definition when we talked about the routine stops, it was 11 hours and 30 minutes. The unexpected stop was 27 hours and 15 minutes. Now to get the OEE, we need to find first the good output in terms of the case, not the tablets. Sorry, in terms of the tablets, not the case, because here the good output was given by cases, not by tablets. So we want to work and measure for every tablet because the production line or the operation will work in terms of the tablets unit because the specified speed was for the tablet. So we have to unify the unit. So the 42,032 cases times the 144 that comes in every bag, it will give us 609,408 tablets. So how we got this number? We have 40 42,032 bags. يعني عندنا 42,032 كيس. each case, each bag, كل كيس has 144 tablets. في كل كيس عندنا 144 حبة. So the total we have, the good output means we have 609,408 حبة للصابون. The effective time in this case, how we calculated the effective time, we divide the good output divided by the specified speed. And pay attention that the specified speed we have was per minute. As we said, we have to multiply it with 60 to get the number of tablets per hour. That's why we have in the denominator here 150 times 60. So you divide the total good over the speed to get the effective time. So what does this time means? This is the actual time you use for the production. The actual. يعني this is the time where every second and every minute was counting to produce those tablets. Okay? By dividing the total amount you produced over the speed or the specified speed you have, which is the 150 per minute. Getting the hours that is utilized for the production or for the producing the goods or the products, and that's what we call it the effective time. The production time, if you recall here from this picture, it was the operation time minus the routine stops. So it is the operation time minus the routine stop, and that will lead to 116.5 hours. 116.5 hours. This is the production time. When we exclude the routine stop from the operation time, so we say the production and operation, they are very close. The only thing between them is in the operation you have the routine stops that consider to be like the setup time or prayers or whatever. Those are routine and considered to be happening in your process. So the production time is 116, and as you see, the operation time 128. So there is a bit different between them, but we can say that it is about 11 hours in terms of the production and operation. And to get the efficiency, now you have the production time and you have the operation time. To get the efficiency means كفاءة الإنتاجية, production efficiency. And we hear this a lot in these days with this national transformation projects going on the government sectors and in the country to serve the vision of the country to improve the efficiency or the productivity of human resources or all resources you have in the country. So in order to find the efficiency, in our case, we have to divide the effective time we have divided over the production time which we just found. By dividing the effective time, اللي هو time you use for producing those tablets, and production time, which was considering the operating time minus or only excluding routine time, we will see how efficiency was, or the percentage of the efficiency. It was 58% only. معناها كفاءة الإنتاجية, it is only 58% in this case. We will, by completing the calculations, we will interpret this number and we will see why it is not high as we expected. Here, it's calculated the total time, and the total time will give us a hint what's happening. The total time in this factory or this production line is 7 times 24, which is 160 hours. So it should be working 24/7. Now, when we talk about some factories like oil factories, gas, petrol companies, even food industries, those factories working 24/7, they cannot stop at any day or at any time, regardless. You are having a grocery store closing on the Friday, maybe a workshop closing during the Friday. Those factories, they cannot work. Otherwise, the whole economy can be affected by this closing. Even when they do down or shut down for maintenance or something major needs to be done, this is rarely to be happen, and usually they have something in alternative working. And because to run off this machine again, it is costly and also it's consuming time. So here in this example, what I'm trying to say, the total time available for them is more than what they are using. Eventually also, we will find also there is unexpected stop time found to be very long, where they can produce a lot during that time. We will come to that. But now we knew that this, maybe you ask, okay, how do I know it is working 24/7? In the example you will assign to do, it will give you that this is factory where it can be working 24/7, or it is limited to work 5 days per week for only 8 hours. So these instructions will usually be in the questions. You were not going to be figure it out because something that has to be given. But because here the example was for a production and packing line for industries, and usually those are working 7/24 or 24/7. That's why here it was calculated in this manner. Now, the other factor we can find, all these values we are finding here, as you can see, it is helping us to highlight where we can improve, where we can focus, where we can also reduce in terms of setup time. Like here, for example, the routine stops, it is about 11 hours. This is related to the SMED approach. They can go and analyze it and identify what is the chances to improve and reduce this, to don't stop the productivity or the production from being performing while doing these stops. So they can do those while the operation is running or while the equipment is running. The operation, speaking about the operation utilization, the utilization, or the operation utilization, means that how efficiently or how you utilize your operating time. How you utilize your operating time. Excuse me. Okay, sorry for that. Going back, the operation utilization, how it's different between that and the production efficiency. Here, the production efficiency كفاءة التشغيل, operation utilization استغلال ساعات العمل or استغلال وقت العمل. So you see the difference between them. How you are utilizing your operations time versus the production efficiency, which is the كفاءة الإنتاجية. So you can see there is difference between them, and we can distinguish between them. One is how you utilize your operating time, and the other one, how efficient is your production. كفاءة إنتاجيتك مقابل استغلالك لوقت العمل. The operation utilization can be found from basically the operation time over the total time to see the percentage. And in this case, the total time here, which is available to be working also, the 168, which comes from the 24/7, and the operation time where they are working is 128, so it is 76%. Not bad, but also can be improved. And these are operating time. You set them for yourself, where is no restrictions to be working 24/7 in your case. So if you have restricted time or the operation time equal the total time you have available for you, that's mean you cannot increase the operation time. معناها ما تقدر تزود ساعات عملك. القطاع حقك ما يسمح. يعني for example, bank, now exclude the bank's branches in the airport. Please don't consider them when I'm giving the example here, because now we're talking about the whole services that can be done in the major bank branches. Now, banks, they cannot exceed their operation time because they are limited to or following the authority or the regulations in the country, which they have this setup operation time. But whereas in a restaurant, you have more flexibility. If you are a shopping center, you have more flexibility, and you can measure that to all the other stores or services can be provided nowadays also online. So you still can have operating time even after the closing time or the store closed. Anyway, just to make the difference between the total time here in our case is different than the operation time, and that leads us 76% utilization of the operation time. معناها بيستغلوا 76% من أوقات عملهم أو بيستغلوا أوقات عملهم بنسبة 76%. Okay? مقابل versus to 58% كفاءة إنتاج. To find then the OEE, the overall equipment, and as we said, equipment can apply to service here, effectiveness, you divide the effectiveness time over the operation time. And in this case, you divide the 67 over the 128, that will give you the 53 over all equipment effectiveness. الكفاءة الكلية للماشين عندنا بنسبة 53%. And this is considered to be a room for improvement. A lot here can be done. And here there is the note where it comes, and we will also come again to those numbers and explain them. But if you subtract the operation time you have from all the stop time you have here listed in the given table, if you subtract the operation time from the routine stop and the unexpected stops they faced, minus the effective time, which is you use for the products, it will give you 21 hours. This 21 hours found to be unrecorded. إيش معناها? We don't know how it was spent. We didn't know how they use it. And this 21 hours, if you multiply it with the 9,000 tablets, this gives us 189,000 tablets can be produced in this time. Why I said 9,000? Because the 150 tablets per minute, if you multiply it with 60 to get how many tablets per hour, that will give you 9,000. So this unrecorded time we could find from the given information, that also give us there is a waste. It has to be analyzed and reduced. Also, the unexpected stop time is very high. And that means there is something need to be analyzed. The routine stop, although we say that it can be improved using SMND or any other tool to reduce this routine stop, but the unexpected stop is double the time for the routine. So there is something wrong going. They have to analyze how to reduce this waste of time, which will definitely increase their production of good output. This is the metric here. This is the major number. This is where if you increase it, you can increase the effective time, so you can increase the OEE in general, and also you can increase the production efficiency. The specified speed, can be depending on different factors also. It could be human training, or maybe training, equipments upgrades. Some equipments can process more or faster than others. The same for human. If they are trained enough or skilled enough, they can process faster than others. So the specified speed, this is something that also need to be analyzed. The good output can be increased by considering that there is a gap in the number of hours they are working and the total time. The number of hours of working, or the operation time, they have 128, whereas the total time available is 168, which is about 40 hours. Those 40 hours, if you think about them, and also include all those routine stops and the unexpected, they still can get thousands of tablets during these hours. So you see how this tool is very useful in terms of you and working as an industrial engineer, how you can pay attention to all the details and how you calculate the different times going in the process, every second in the process, every second during the operation hours and the operating time, and allowable time for your business. It counts. If you increase the number of goods that you can produce every day, how? As we say, many directions can be done. Now, this is depend on the resources and the situation. We can increase this number here, which is the good output here, that driven from this number, that given, by different dimension. We can increase it by either increasing the operating time, by reducing the unexpected stop, or reducing the routine, as we just did in the previous tool in the SMED, or working on those unrecorded time and see what's happening here, why there is no productivity, where is this 21 hours of that week lost. So all these analysis will lead you to several directions for improvement to reduce this waste or unadded value time in the operation, as well as to increase the efficiency for the production and overall equipment efficiency. This is a very good tool, and it can be applicable and implemented in both manufacturing or production and service. Moving forward with other tool, which is the 5S. The 5S is being covered in the Six Sigma review session. The 5S here, we give more details about it. It's a discipline itself, the 5S. It's improving the housekeeping of on operation, the workspace and the organization, by implementing a sequence program called the 5S. Starting those 5S Japanese original words where it's driven from, and this is the translated English words. The sort, you start with the sort by identifying and segregate the unwanted things, meaning that those tools, do you need them in this workplace? Yes, then you put them on a side. Are those tools or these equipments or these papers needed? No, then you remove them. Then you move on to set in order. So you have those tools. So you put them in order. You don't mix them together. So you put the screwdrivers together. You put the saws, the wrenches together. All these type of tools, you put them in orders and you separate them in different categories, and make sure there is a place for everything and everything in its place. So no tools is in the surface just to keep it, or just in randomly you put it in a drawer. Everything has to be organized in a place, and every tool is placed on the right one for it. Then you do the third step, which is shine. Always keep the workplace area neat and clean, so you can detect anything that may cause defects or causing and applicability to achieve or reach your tools. Standardize, maintain high standards of cleaning and workplace. For example, sometimes you can use like those yellow tapes, so you can have this area only where those tools placed, so those cannot be removed to out of this square. And also this means the working area, so no one entered this working area except maybe with a certain permission or certain dressing code for safety purposes. Also as well, tools cannot be out of this area without permissions for maintenance or so on. Sustain, which is the last step. The 5S itself needs continuous improvement, so always you keep continuing improving for these other previous 4 steps. And you can use also to maintain your improvement, having like check sheet for your tools that someone is to audit the working area and make sure that monitoring everything placed in the right place. So these are 5 S's. Wide range of application can be done. I advise you to watch the Six Sigma case study recorded session. 5 S's has been implemented in the post office along with other improvement good tools there to show you how using 5S utilize the working space and improve the workflow. This is an example here. Also, it's being done in a company that for a delivery process, they use 5S and they reduce the space where the employee travel by 93%. Imagine how difference that make in the workflow. Also, the overall floor space is being reduced by 42%. This is going to definitely impact on the productivity, impact on the sustainability of the performance, and the working also environment for the people. As you can see here, this is just a figure to show you that you sort the tools that you need them, you put them in separate sections, you set them in order. So for example, the red ones here by the color, it could be the functionality of the tool or the size. It doesn't matter, it depends on your case. Then you clean always and make the work areas clean. You can use, as we said, some tapes to also standardize or make the place looks neat. And standardize the process. Instruction can be also written, so anyone work in that area knows how to follow the 5S concept that you implemented by returning the equipment in the right place, how to use the equipment, how to leave the place clean as you receive it, and so on. And sustain and make always continuous improvement and checking actions along the way. This was for the 5S. The last tool, not least, is the brainstorming, something that most of us we are aware of, but always ideas come from brainstorming, whether we follow a tool or by just sitting thinking about all those ideas for improving a process. It's a tool itself, whether you use it as a systematic way as it's defined here, or in just giving a quiet place where you think and how you improve or solve your problem you are facing in the process. Brainstorming is an improvement tool for a team usually to generate creatively and efficiently, and I emphasize on creative and efficient, because not every solution is creative and not every solution is efficient. High volume of ideas, so not you just come with one idea, you come with high volume of ideas on any topic by encouraging free thinking. There are two ways or approaches for the brainstorming, either the structured approach or the unstructured approach. The structured approach, or known as the round robin, is you ask each member to give an idea and moving forward to the next one. So everyone just give an idea and someone write and record all these ideas, and everyone has to be in that round to give an idea, and then they discuss all these ideas and give more, or they give all of them, all the ideas, all the rounds, they finish them, then they discuss the ideas. The other technique is the unstructured. They call it the freewheeling, which mean that idea can be expressed by any time by anyone in the team. And brainstorming, there are rules for the brainstorming if you would like to conduct it in this manner. Deferred judgment, so avoid judgment, don't judge other, so don't say, and for example, your idea is silly, your idea is, don't do that. Encourage wild ideas. Creativity usually come from wild ideas. Build on ideas of others, which means that if someone give an idea and the second one in the round, if you are using the structured approach, he build upon the previous one's ideas. Stay focused on the topic, so don't be distracted and try to focus on another problem or another process. One conversation at a time, which is very useful to control the time in terms of the ideas, so it will not be openly wide, so you consume the time by just discussing over and over. So one conversation at a time, and it's need to be, there is a leader and timekeeper and recorder for those brainstorming session. Be visual and go for quantity, especially in the brainstorming, go for quantity. As many ideas you can generate is good. This is just to open the floor for any suggestion. By this, we can say that we finished the improve phase. As we said, this is one of the largest phases that can carry a lot of tools that even out of the scope of quality, as long as it serves the purpose of the Six Sigma project. I will see you in the next session with the control phase and the control phase tools. See you.